so that we know what we are working with. I'm just going to come here, going to put the struct here. I'm going to comment it out for now. Over here, so let's define the params. So the params we are passing in, which must be this struct. We've imported the struct from the interface, and so this is the struct itself. So it must have token in, token out, just as you have seen it here. Fee, recipient, amount in, amount out, minimum, and this. All right. So we need to supply these parameters. Let me zoom in on this amount out minimum because it's quite important, and this is how we are going to get it. Now, what does it mean? Amount out minimum means that if we want to swap one wrapped Ethereum now, let's say the price is currently $4,000. So we want to swap it to USDC. So we are supposed to get 4,000 USDC. We are stating to Uniswap V3 with this amount out minimum that don't give us anything less than 3,990. Because when we are swapping on any AMM, this price of the pool can change at the time we are even swapping. So the price can be 4,000 at the time we sent our swap to the pool, and during the swap it can change from 4,000 to 3,000. So we are now saying with this amount out minimum that if the price changes, no matter how bad the price changes, we need minimum amount of 3,990. If you can't give us minimum of 3,990, cancel the swap. So that means that we need to calculate this amount out minimum. So we are going to be calling Chainlink to get the current price of any token we want to swap. And in this case, we'll be using Worth USDC. So this is a function that will help us to fetch price from Chainlink. And these are the parameters we need to pass in. I'm going to also explain this. Well, so let's implement this get amount out. So in order to interact with Chainlink, we need two things. We need a library and an interface. So we can do that by what we did for OpenZeppelin, using Forge install to install the contract for Chainlink, or we just pick those two libraries and the library and the interface we need and just import it. And that's what I'm going to do. I'm going to do the second one. So I'll come here, I'll create a folder called and name it library. Inside it, I'm going to paste this price converter library. Now you can see it imports an interface called aggregator v3 interface. So we need to put that in our interface. So I'm going to come here and I'm going to paste the interface here, aggregator v3. Again, I'm going to leave the link to this, to Chainlink documentation, in the description of the video. As you progress, you'll see how we are going to use these two things we've just imported. So let's come over here and import the two of them into our contract, the price converter library and the aggregator v3 interface. So over here, just down here, I'm going to import the price converter library for uint 256. All right, that's how we import the library into our contract. I'm now going to come down here and implement the function. So this is the get amount out Chainlink. I'm making it a public function. Public function is a function that can be called by other functions within the contract and can also be called by external contracts or external addresses. So this is going to be useful for us to just get the real-time price of any token we are interested in. So that's why I'm making it a public function. Now, if you notice, this is amount in. This is the value of the token we want to swap, amount in. Because we have defined it, it's a unit 256 type. So because we have imported this library into this type, then we can now call it like this. We'll call this get conversion rate function on it. Where does that come from? So I can just press command down and click on this. You can see where it takes us to. It takes us to the library price converter. So inside the library price converter, it has this function conversion rate, get conversion rate. What this does is whatever the amount you send in, and you have to supply the address of where you want to get the price from in Chainlink. So Chainlink has address for each pair you're interested in. So for worth USDC, if USDC, you'll get the address. All right. So from here, we are able to fetch. So it calls this gets price. This gets price function is what brings in calls to Chainlink, and we get the answer we are interested in. This is just to compensate for the units. All right. So it returns the price to us. Back to our code. Now, when we have the price, we now have to compensate for token decimals. Now, to explain that, every ERC20 tokens have their own decimals. So a good example is $1 can be splitted into 100 cents. Right now, in the case of some ERC20 tokens like wrapped Ethereum, it can be splitted into 10 raised to power 18. Yes, 10 raised to power 18. So one ether is 10 raised to power 18 way. All right, that's how the smaller units works. So one ether equals 10 to the power of 18 way. I need to write this as double. All right, that's how we write it, to the power. All right, so this is meant to be equal. All right, so that's it. So we need to compensate for USDC. It's 1 USDC can be split into 10 raised to power 6 decimals. So they have different decimals. So the multiplication and division we are doing here is just to compensate for the difference in their token, their decimals. All right. So after that, we'll get the price will be returned over here. Now there are a few other things. Now, we don't need this anymore. I can just delete it. Now, if you notice, we need to supply few things as parameters here. Price feed address. We already know this. We know this. We need to get the decimals for the token we are passing in and the token we decide our desire what we are going to get out. So this is how we need to the token address we are passing in. We need to wrap it around this ERC20 token so that we can call the decimal function on it so that we get its decimal. The same thing for the token out. So this can be wrapped Ethereum, this can be USDC. Then, so for us not to get this error anymore, we need to import this ERC20. The contract. Now, Open Zeppelin will also be useful here now. Here, from Open Zeppelin, we are going to get this ERC20 contract. As before, we have our curly brackets. All right, so that's it. The next thing, all right. So the rest we can pass them as parameters. Now, another thing you need to notice here is that we are approving the token in. The token we are sending into Uniswap, we are approving it. We are giving approval to Uniswap V3 to take it from us, and we are stating the amount. So, yeah. So let me define the parameters now. So I'm going to come here and define the parameters. Now, please, I would urge you to code along with me. If I'm going too fast, you can slow me down. Or if I'm going too slow, just use the settings on your YouTube and go at a faster pace. But at every point, endeavor to pause the video and copy the code. All right. So, yeah, there are still two parameters we are yet to define: slippage number times 10 raised to the power 8 and whole percent. So, I'm just going to come up here. I'm going to define them and we are going to have a little discussion. So, here, just yes. Now, whole percent should be 100%. This slippage is for us to define our slippage tolerance, which is going to be 0.5%. Ideally, it should be between less than 1%. What sense? If our slippage tolerance is 1%, what we are saying is if the current price is 4,000 USDC for one wrapped Ethereum, and we want to swap one wrapped Ethereum to USDC, we are expecting 4,000 USDC. Our amount mean would be 99% because we have 1% slippage tolerance, 99% of 4,000 USDC. So if after the swap, what is going to give us is less than 99% of 4,000 USDC, the transaction will revert. Now we can also set this to 0.5%. Of course, now that means we have a lower slippage tolerance. Now that's the whole essence of this slippage. Now, this is quite important because there's a major security vulnerability related to this. You must have heard of MEV bots before. Now, there are bots whose job it is to always look out for every transaction in the mempool. Now, mempool is a place that your transaction goes to before it's processed on the blockchain. So, these bots look out for every transaction in the mempool. And if you are going to swap a big amount of token, their job is to ensure that you get the worst possible price. Now, how does that favor them? What happens is once they see your transaction in the mempool, these bots quickly prepare their own transaction and swap before you. They make the swap on Uniswap v3 before you. How they do that is that transactions, miners are allowed to reorder transactions on Solidity in EVM. Yes. And so basically, because they are paying higher transactions, higher transaction fee, higher gas fee, their transaction will go before yours. So they are able to swap before you, adjusting the price upward. And when you do your own swap, you're getting a much higher price than you thought, and immediately they sell after you again. So they must have bought at 4,000 USDC, and the price becomes 4,010 USDC. So you make your swap at 4,010 USDC. Then they sell immediately at 4,010 USDC. In that case, they've quickly made a 10 USDC profit. So that's why this slippage is quite important that you state. We don't, that if the price I'm getting is worse than 99% or 99.5, yes, it's beyond 1% tolerance. I do not want that. Now, a whole percent is meant to be 100, as we know. But unfortunately, or as by design, EVM does not cannot undo decimal points, because this slippage value will now be 99.5 because we are targeting 0.5% slippage. Now, once it sees this, it's going to round it down to 99. So automatically our 0.5% becomes 1%. We don't want that. So because of that, we are going to be using big numbers. So our 100, we are multiplying it by 10 raised to the power 8. So it's like saying 10,000 times 10 raised to the power 6 for a whole percent. And we are going to subtract our 0.5%, which is 50, then we'll take it away from 10,000. So it's going to be 9,950 times 10 raised to the power 6. That's meant to be our slippage. So here I'm setting it to 0 because we are going to test on local chain and on the testnet, because the liquidity on the testnet is quite minimal, quite small, and so that we don't get our transactions reverted. That's why I'm going to set it to 0. But don't forget, if you are going on the main net, please, this place cannot be 0. All right. So I'm going to come here and also add an helper function to help us adjust the slippage at any point. So here we are going to, if we have a new value that we want to put in, we are going to assign it in here, and our slippage number times 10 to the power 8 will be calculated here. All right, and we are going to emit an event. So if the value we are putting in is more than a whole percent, it's going to revert. So I'm just going to define this error up here. This is where we define our error. I'm just going to come to the event side of things here and also define this event. All right, so no more error. And that also means that our internal function of Uniswap v3 has been completed. So we need to expose this internal function now. I'm going to come up here and create a corresponding external function. Okay, let me just remove this comment so that it doesn't confuse us. All right, so basically you can see the function swap. It's an external function and it returns the amount we are getting out of this internal function. Don't forget, our internal function, we can't call it outside the contract. So that's why we need to expose it. So, but before, what this line does is that it takes the token we want to swap from us, who is msg.sender, whoever is calling this contract, and transfer that amount to this contract. We are using safe transfer from. All right, it's also a function on ERC20, but it's safe because it handles all kinds of ERC20 tokens. So because some ERC20 tokens implement transfer from differently, so we are going to have to use safe transfer from function, and it comes from another library that we have to import from OpenZeppelin. So here is the library, safe ERC20 library here as before. Here now, over here we also need, since it's a library, we are going to say that we are using it for IRC20 interface, and that will ensure that it is available here for us to use. You can see the error has disappeared. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. I'm currently creating a 12 to 24 weeks training course on smart contract development, auditing, and blockchain decentralized application automation. It's going to be a comprehensive training course, and mainly it will be a one-on-one section. I'm not taking more than 10 students at a time, and so that I can take you from any level you are in, whether you have written code before or you've never written any code before, and make you into an expert. If you are interested in this training course, please leave your comments below, and once my waiting list page is ready, of course, I'll let you guys know. With this, we have completed the functionality for swapping on Uniswap V3. So let's move on to Aerodrome V2. As before, we are going to define an internal function here, which is going to return our amount out. Let's take a look at the interface. Again, when you want to interact with a deployed contract on the blockchain, you need the interface and the contract address. So for Aerodrome V2, we've imported the interface earlier. So this is the function we're going to call, and it's returning array of amounts. So one of it is our amount out. So let's implement this. We come here, and this is how we are going to call swap exact tokens for tokens function. We've not defined our Aerodrome router. That's why we're getting this error. So let's define this router, the contract for Aerodrome itself. Firstly, we need to get the contract address for Aerodrome V2. So I'm just going to come down here now. I'm going to define the contract address here as a constant. So this is Aerodrome V2 router contract address. I'm going to, as before, leave the link to the Aerodrome documentation in the description of this video, so you'd see how to get this contract address. Now, because Aerodrome is only available on base mainnet, then I can afford to define this contract as a constant here. This contract, we are not going to be able to deploy it to other blockchains because Aerodrome is not available there. So that's why I named it based to other chains color. All right. So yeah, we have this. Now, Aerodrome also requires this Aerodrome factory address. Again, it's in the documentation. So we have the contract address, we have the interface. So let's now instantiate the contract. I'm going to come here and define the contract itself, Aerodrome router, and it's immutable. So that means I have to come to the constructor and initialize the contract itself. So let me get the interface. You have the interface here. All right, Aerodrome V2. I'm going to wrap it around the contract address, which is this. All right, so we should stop getting error here. Yes, so this is the contract, and we are calling this function on it. Let's define each of these parameters. Amount in, we can easily supply it by ourselves. We need to get this amount out minimum. This is route. This route comes from here in the index. It's this route, and it's struct is a type of this struct. So we are going to define this and put all these variables inside it. You can see the Aerodrome factory address we got. This is where we're going to pass it in. So I'm going to come here now and define the missing parameters. Now, let's look at this. The first thing we've done here is to approve Aerodrome contract, Aerodrome V2, to take this amount of token from us so that I can swap it. So this is token in. The token we are giving Aerodrome V2, and as we've been saying, it's wrapped Ethereum, for example. So that's the token in, the amount we are giving it. And so yes, token out will be the amount, the token we want to get back. In this case, the illustration we've been using is USDC. So I need to state that. Now, this is how you define a variable of type of this struct. So you can see I brought it from the interface itself. Aerodrome v2 router. And this one means that this route is an array, but it can only take one element. So if you have an array, array data type, the first element position is 0, then you have 2, then you have 3, and it goes on and on like that. So when you define it that the size of this array length has to be 1, that means only one position. That's what you're going to have. All right, so it creates only one position for this array. Now, the first position and the only position we have is 0. So we are going to assign value to it. So we call route again on the interface. Then from, we need to assign value to from. You can see on the over here in the interface, you have from to stable and aerodrome factory. So we come here. From is the token we are sending in. We have the Ethereum contract address. Token out is USDC address that we want to get. Stable means are we swapping stable coins? We are not swapping stable coins, so it's false. And the aerodrome address, aerodrome factory that we got up here, that's what we are passing. All right. So yeah. Now, of course, we need to now get the remaining ones. We can easily get these 3 parameters. Amount in will specify the address of token in and token out. So yeah, but what we is the we need to calculate is our amount out minimum. Address this is the address of where we want Aerodrome v2 to send our token to after the swap, and it's this contract. That's why you see address this. Block timestamp is how we get the current time on the blockchain, plus duration. Now this duration is how many seconds we are giving Aerodrome to do our swap for us. So we can define 30 seconds, 15 seconds. Now this is deadline. If we come back over here, you see it as deadline. Yes. So that means that if it takes longer for you to swap it, if it takes more than 15 seconds, cancel the transaction. These are the ways